Hello everyone, my name is Shifra. Welcome back to my YouTube channel, and I'm designing an AI model that can be used to detect breast cancer. And this is a breast cancer dataset, and it has many features, as you can see here. And it includes radius, texture, perimeter, area, mean, many things. And then this ID represents the IDs of the patients that think they have cancer, they come for a diagnosis. So the results would be M or B. M meaning that someone has cancer, it means malignant, and B means benign, meaning that person does not have cancer cells. So this is how my data set is going to be used to solve the breast cancer. So this data set includes all these features of a woman's breasts, and they are measured, and the results that are gotten. The system uses these results and gives a response of B, which means the person is not affected, or malignant, represented by M, meaning the person has breast cancer. So the factors that I considered in order to get this data set, I considered the fact that it has labeled fields, and they are well labeled in a way that it is obvious that the fields and their values have enough data about them, and you can easily understand what they mean and the results. It has almost enough data to be used in testing and training the artificial intelligence. Okay, with these data sets, 20% of this data set can be used to just test the system, like testing it and showing what the results would be. And then the 80% of these can be used to train this data set, to train it in a way that if something like this has happened, if these symptoms have been seen, have been detected, someone has cancer, give an output of M. And if these are not detected or they are not prior, then that means the system gives out this B, meaning the person doesn't have cancer cells. It is also accurate, it's up to date, it's so recent. The data that has been gotten is so recent, meaning the results from the model are so reliable and they apply to the day-to-day living of women. So the features that this data set is going to mostly consider when detecting, first of all, it will have to see this ID number. This is what is easily identifies the patient who is likely to be suffering from breast cancer. That record is taken, and then we have this diagnosis of the breast tissues, which includes B for benign, though I explained it already, and M for malignant. B shows that the cells are not harmful and one has not gotten cancer cells yet, while M shows that the cells are infectious, meaning someone has breast cancer. So then there is the radius mean. This is the mean of distances from center points of the breast, meaning from the nipples. Then the texture mean, this measures the smoothness or roughness of the breast. So then we have Bayesian theorem. Bayesian theorem determines conditional probabilities. That is the probability of one event occurring given that another event has already occurred. For example, if a lady feels a solid lump in her breast, there is a probability that there is an occurrence of breast cancer. So this is how Bayesian theorem is calculated. The probability of A given B. So meaning, given B, A happens. So if there is a cancer lump, like there are dead cells in a breast and there are solid lumps in a woman's breast, meaning that woman might have breast cancer. So given the solid lumps, given the dead cells, then there is cancer in the breast. So P of A, that is the probability that A happens, P of B, the probability that B happens, and P of A given B, the probability of a condition when A is occurring, while event B has already occurred. That's all for Bayesian theorem. And then now we go to Naiv's Bayes. Naiv's Bayes is called naive because it assumes that the occurrence of a certain feature is independent of occurrence of other features. It classifies data into various classes with accuracy and speed. So the presence or absence of one variable does not impact that there is the presence of or existence or absence of any other variable, meaning all things appear on their own. The features are on their own. They do not depend on other features existing. So now we have advantages of this. So it's just naive, then it has advantages. This is called naive because of all this, because for it, it thinks everything, it implies that all features are independent of other features. So the advantages, it handles both discrete and continuous data. It is fast and can be used to make real-time predictions. So then we go to Bayesian network. Bayesian network is ideal for taking an event that occurred and predicting the likelihood that any one of several possible known causes was a contributing factor. For example, this Bayesian network could represent the probabilistic relationships between diseases and symptoms, like those relationships between symptoms and diseases, that given these symptoms, all these symptoms in a person, then there is a probability of this certain disease. And now we are dealing with cancer. If there is this symptom in a person, then there is presence of cancer cells. So someone has cancer. So I'm talking about the differences between these theorems. We have Bayes theorem and naive Bayes. So naive Bayes, for it, we have already talked about it. It assumes each input as independent, as an independent variable. The presence of one feature in a class is unrelated to the presence of any other feature. While Bayes theorem assumes dependence. For Bayes theorem, it assumes that something occurs because another thing has already occurred. It occurs due to the presence of the other. So the occurrence of one event is due to the occurrence of another event. Someone has cancer because she has lumps, because she has dead cells, because the conductivity is so large. That's what Bayes theorem is all about. So now we have the difference between Bayes theorem and Bayesian network. Bayes network requires enough data about different features in order to derive relationships between them. It has to have enough data for it to differentiate those features and then talk about their relationships. But with naive Bayes, features are class conditionally independent. They are on their own. Each feature appears on its own. And given this feature, it doesn't mean that there is another feature. And it requires less data to get a good result. And then, yeah, that's all. And these are some of the references in case you want to get this work. This is a link to the database that I got. And as you can see, I just gave a small screenshot. And if you want to get more of the data, it's with this second last link. Thank you so much for listening. Have a nice day.